You may start now, sir.
Okay, thank you very much, Dr. Varun. I, Dr. K.K. Singh from MIT University, Uttar Pradesh, Lucknow campus, welcome you all to this technical lecture of Professor Gaurav Verma. He is a assistant professor at JP Institute of Information and Technology, Noida, and we have many distinguished guests in this panel. I welcome one and all. This event is being organized under the banner of IEEE Young Professional UP section, IEEE AUP Lucknow campus student branch, and IEEE student branch of Dorat. Dr. Varun Kakar, Chair, IEEE UP section, has played an instrumentation role to organize this activity, a technical lecture series and a professional lecture series. And this lecture series is being sponsored by IEEE Region 10 and IEEE Young Professional Region 10. I welcome you all to this 5th technical lecture, which will be taken by Dr. Gaurav. And he's a man of embedded system, IoT and machine learning and artificial intelligence. Dr. Gaurav has 70 research papers to his credit, and he has done a project and has 2 patents also. So I welcome Dr. Gaurav on the behalf of IEEE UP section and IEEE Young Professional UP section to deliver his talk. Welcome to you, sir.
Oh, so should I start the session?
Yes, sir. You may start now, sir. I request all of the participants to please switch off their mics. All the participants, please mute yourself. Dr. Gaurav Verma, you may start now.
Let me share my screen. So is my screen is visible?
Not yet, sir, but it will take time.
Dr. Gaurav, your screen is not visible.
Let, let me try again. And now it is visible, Dr. Varun?
Yes, sir. Now it is visible.
Okay. Okay, then let me start. Already lots of time has been gone up. So I first of all thank you, Dr. Varun and Dr. Kamlesh Kumar for inviting me for delivering the lecture on the topic that is role of AI in IoT and related case studies, right? So I request the audience that I would be starting this particular session, and if any at any point of time, if you will find any doubts, then you please let me know. For the same, you can stop me and raise your query. Okay. So let me move on to the first slide. We are going to cover the following contents. Contents in this particular lecture. That is, I am going to focus first of all about the introduction with the IoT and various communication models, different networking protocols that are has been used and incorporated at the TCP/IP model, specifically for IoT applications. What are the various hardware platforms and cloud platforms available in IoT, and what are their features? Which particular hardware platform you can choose for building your projects and applications at the education for the educational purpose, and what are for the industry purposes. Then we'll switch over towards the concept of AI and see the role of AI in actually IoT, right? And the session would be ends with some of the case studies and some of the hardwares, introduction of the hardwares that are related to the that can be utilized for the purpose of uh, putting AI onto the hardware, for running the AI into the hardware setup. Because there is a big question nowadays that how can we design a system which can support an ML algorithm, embedded system. Okay, so we'll see what are these hardware accelerators. So let me start with the topic that is first of all Internet of Things. So as you can see, this topic is Internet of Things is the combination of two words. One is called Internet and another is called Things. Okay, so Internet, we know that it is nothing but it is a network of networks, and it can be utilized for transfer of data from one point to another point. And yes, it is utilized TCP/IP protocol for this particular purpose. So we are very much aware about the internet structure. We already have some subjects at our BTech and undergraduate level regarding this. So internet is not a new word for us. The new word is IoT when it is combined with things. So let us concentrate on this part. What is basically a thing in IoT scenario? So in an IoT scenario, a thing is nothing but it refers to an embedded device basically. Embedded device uh, means the systems that are the legacy systems that has been developed that we are developing from the last 10 to 15 years. We are very much aware about the embedded system technology, and we are developing these systems. So, but when these embedded devices equipped with sensors, actuators, and also a communication interface in some of the cases, when provided with the internet point, or you can say when they are having some IP address or given some IP address using a suitable communication interface, and when they are connected with the internet structure, then what we can do, these devices can send data over the internet to some remote places which are very far away from each other, or some remote devices which are very far away from each other. So this is basically the main concept lying behind that. The devices over the internet can communicate with each other and exchange the data with the help of internet. So this is the basic root and purpose of IoT, that in future the devices would communicate with each other, exchange their data, control each other without the human intervention, that and using the internet structure that we already have from the last 10 to 15 years. Okay, and now and this is not a new thing, that if I would say that some of the examples of embedded systems are the mobile phone, TV, fridge, door, wearables, soon you will see that all these things are being smart. We are in the era that we are seeing this development, that uh, previously there was a TV, and now we have a smart TV. Okay, so smart TV means there is some already some internet feature is there. You can connect your TV with the internet. So already some devices are equipped with this. Soon you will see that your microwave oven, your fridge, or even small devices are coming up with this particular smart feature. And what happens in a coming scenario, that all these devices are able to connect with the internet, and we can communicate, we can send, we can these devices communicate over internet with each other and control itself. And yeah, this is the main advantage of using it. But as you can see and understand that every advantage is having some disadvantage, so we'll see what are the disadvantage of this technology later on. Now let's move towards the next slide. So this is basically the picture to visualize that what I'm trying to convey to the message to you people, that internet of that thing is nothing but it is the basic big backbone or a structure. Okay, and through which actually we have seen that the devices all around the world, they can connect with each other. Okay, because internet is all over the whole globe, the whole earth can be connected with each other from one point to another point. The devices on the earth can be connected from one point to another point. And in somebody ask you what is the simple definition what we can have in terms of the IoT. So in 3 lines you can explain them, that internet of things is the network of physical objects and things embedded with electronic software, sensors, and network connectivity, which enable these objects to collect and exchange data. Right. So this is the simplest definition, that if somebody asks you that what is how can you define an IoT, so you can provide the simple definition in the context that I told you. Right. This is a photo or picture, you can say, that which I have taken from the internet. What it says that how evolution of IoT has been taken place basically. So if we'll look back way back in 2003, then you can understand that in 2003 we have this picture told you that in the brown area covered by the circle, and there is a blue area which is also a small circle. So the brown area which tells us that how many number of peoples on the earth as compared to the number of people's number of things connected to the internet. So you can see in 2003 we have a large brown circle, and very few peoples are very few things basically are connected with the internet, were connected with the internet. Now, as the things has been progress, evolution has been done, no development has been taken place. In 2010, in 2015, you can see this blue circle is keeps on increasing. And now the scenario is we are in the era of 2020 and 21. Okay, and you can see that IoT is now a big word, and we are very much aware about all these things. We are seeing the developments and the things that are happening. More and more devices are coming up with the internet facility, smart facility, and that's why more number of devices are going to be connected with the internet soon. So by 2020, it was expected that it would be 50 billion, and by 2025, it would be going to be one. Uh, uh, you can say one. Uh, Around 100 billion basically. Okay, it is going to be 100 billion devices. So in by 2025 itself, right? So this is basically you can say this is basically a concept, and that is keeps on rising, that how fast the things has been evoluted, and it is going to increase the number of devices that are going to be connected. So um, as I told you in the previous slide also, when the things are evolving at a very fast rate, definitely there are some challenges, right? So we'll see what are these challenges later on. Now the question is that why we have to understand IoT and what are its application industries, or where we can apply this basically IoT. So as you people understand that embedded system is we are working on embedded systems, and we are already have familiar with the embedded devices. Okay, and in general, if we'll talk about a human house, okay, a simple house in India itself, then nowadays that around 20 to 25 we are surrounded with around 20 to 25 smart devices or embedded devices, and actually we are not aware about it. Okay, some of us, we are not aware about it actually. So we are around surrounded about these devices, and this IoT is having application in every aspect. In every aspect means it is having application in wearable devices. Now smart watches are there. It is having application in retail sector. You can see the Amazon in Amazon online shopping, which is going to be revolutionized, right? And then it is also having in automation. Okay, so this slide will give you the information about that, where you can apply basically the what are the different application, what are their percentage where IoT can be applied. Next, we will talk about the companies, just to motivate us that where we can actually, and after learning this IoT or understanding this IoT, where we can apply basically. What are the companies that are dealing in that? And you will be amazed to know that IoT is not a single technology, or not a single thing that only a particular, it is applicable only to a particular industry. IoT is a big framework. Okay, and in that framework we have lots of things, right? Lots of things means there are lots of technologies used. We have a embedded system technology, we also have a web development technology, we also have a networking technology, we also have a cloud technology. So it is an amalgamation of different technologies which are connected together so as to perform this task. So you can understand that every company, whether it is a semiconductor company, whether it is a hardware company, whether it is a software company, it is a retail company, even a market research company, everybody is nowadays every company is nowadays using the somewhere somehow the concept of IoT, either in their devices, either in their applications, or for the networking part, or for some other purposes. This slide just give the information that what are the percentage ratio that we have um, of a particular company in the IoT. It is just the information just to motivate you that yeah, we have jobs in every sector. It hardly matters, right? So that is a small introduction why what is basically an IoT, and what are the companies and what are the applications of IoT that we can do. Now let us understand how can we set up an IoT framework, and what are the ways that device can communicate with each other? What are the different communication models that has been suggested, and what are the different ways that we can utilize these communication models to exchange the data over the internet? So the first model that you can see over here is showing you that there are two devices. One device is D1 and another device is D2, and they are directly connected to each other. Okay, so device D1, there is some embedded device D1 and there is embedded device D2, and they are connected by means of some protocol mechanism with each other, right? And they are exchanging the data. They can exchange their data, okay, from each other. And in this particular model, it may not be necessary that these two devices may be connected with the internet. Okay, it is not necessary. They can communicate with each other, but it is not necessary that they have the internet. This model, this communication model is referred as device to device communication model, and sometimes also referred as machine to machine communication model. Okay, so as I told you, this model requires at least two devices, okay, without involvement of the internet. Just without involvement of the internet. It may be possible. It may or it may be not involve the internet. It may use some protocol mechanism. Okay, there may be a wireless communication or some wired communication, and some wireless, if they are connected using some wireless communication technology, they may utilize some protocols. Protocols are, for IoT protocols, there are BLE. It is the advanced version of Bluetooth, which is specifically for Bluetooth low energy, specifically designed for the low power applications, because as we know, embedded systems are battery operated systems, and we require and we want them to be work as long as possible, and the battery should last long. Okay, so for that we require some of the features that particular device support, and that feature is that we have utilized, we have to reduce the power at every level of the design hierarchy of this particular embedded device, or we can use that type of equipments or components that supports low powered development of low powered embedded devices. So BLE, Z-Wave, and all these are nowadays coming up with the low powered version, and where they can support in the IoT environment. Okay, so this is where, this is what the first and simplest model, that is we can refer as a device to device communication model. Next model is device to cloud model. Okay, now in this particular model, what we have a device, okay, and that particular device can communicate, either can communicate directly to the cloud. Cloud is nothing, a cloud, you can understand, it is nothing but it is a storage space. Okay, and why this model is there in IoT? Because a device, an embedded device, actually it will see, is having very limited resources. Okay, because that's why it is referred as embedded, because everything is embedded into a small system, and that system is having very limited resources. Limited resources means memory, specifically memory to store the data. So what we can do, either we have several options. The several options are, either we can connect external memory to the device, but what it does, it will increase the cost as well as it will increase the size of the device. We want compact device in IoT environment. So, but if we want to store large data, so we need some space. The best way to utilize to store that data is to buy a cloud, okay, or use the free clouds, okay, to store the data. And with the IoT, it is possible that we can connect our device using some communication interface or some a protocol with the cloud. The best way of connecting this to the cloud is you can utilize Wi-Fi or Ethernet. Wi-Fi is the wireless communication technology, and Ethernet is the wired technology. So you can directly connect your device with the cloud environment, either using this, either of using these technologies. Right now, this in general, I have seen that the students, BTech and MTech students, utilize this simplest model, and this model is very much suited because what they can do, they can show up their projects and configure the clouds, and show up their projects in the way that they can provide internet to the device with the help of their mobile phones. So it will become the router. The mobile phone become the router which is providing the internet capability to the device, and with the help of that internet capability, the device can communicate to the cloud. Okay, right. So, but what is the problem? There is a problem with this model. The problem is there is an issue of interoperability. Now, what is this issue of interoperability? This is a very important question, and this term is several times has been flashed whenever you are learning IoT, or when you are come across the IoT. So wherever you will read research papers or somewhere documentations related to IoT. So this term has been populated many times in front of you, and the issue of interoperability. Now, what is this interoperability? Now, the interoperability means basically, let us understand this issue by taking an example. Right? Suppose there is a vendor. Okay, suppose there is a person, and that person want to, let's say, uh, make they automate their room. Okay, with the or automate their house with the IoT technology. Okay, they want to make their home smart, and every devices like fan, tube, fridge, and everything they want to automate. Okay, they want to make it smart, completely smart. So what they want that every device should be there should be some devices, okay, like D1, D2, D3, D4, like these devices, and they have some IoT sustainability, so that these devices will become smart and they can communicate, or I can control them, or I can monitor the status them, okay, over a single platform, right? Now that particular person will go up to a client, will go up to a vendor and ask the vendor that yes, I want to automate my house. So what there is a case, the vendor will provide a solution. Okay, yes, I have multiple devices, and you can use these devices to automate your home. And but all these devices would work on Wi-Fi only. Okay, and you have to buy them. So and every device will cost somewhere around 20,000 rupees, right? So using this particular device to cloud model, what the client restrict the or the person restricted to use that particular Wi-Fi modules to connect its devices using this particular model. And there is a monopoly of the vendor that, okay, because there is no other solution, that's why you have to use these devices only, and you have to pay for that. So in that case, and this is what we called as the issue of interoperability. How? Because let's say there are some other devices also, but they do not support Wi-Fi, but they support different protocols. The protocols may be there may be a device which will support BLE, there may be a device which will support ZigBee, there may be a device which will support some other RF. So there are some devices which will support different protocols, but because the vendor want to make use this model, so in that case there is no option for that other devices which work on protocol. That device must have the which must have Wi-Fi or Ethernet capability. Okay, so this is what we called as interoperability. Other devices having different set of protocols cannot be connected using this particular model. Every device should have the same set of Wi-Fi, Wi-Fi connectivity, Wi-Fi communication interface or Ethernet communication interface. Okay, so लिखा भी है मैंने, this is written, the multiple devices from different manufacturers have different set of protocols, and that's why this issue is there. For to solve this particular issue, there is another model, and which is a more generalized model basically, and it is going to be utilized in general to automate smart buildings or smart homes basically. Because in that case, what is there, what we can do, we can connect basically a gateway. So there is a device to cloud model, but via IoT gateway. Now what is this gateway? A gateway is nothing but it is a uh, um, it is an interface basically, okay, and which provide you the capability to connect multiple devices having different sort of communication protocols with the cloud, having with the help of Wi-Fi or Ethernet. So you can see that there is in this picture that there is a gateway in between, and in between this gateway, at the input side of this gateway, it is supporting different set of protocols, so that different devices of different having different protocols can be connected. And at the end, it's another side, at the output side, it is having the capability to connect with the use the Wi-Fi or Ethernet technology to connect with the cloud. Okay, so this gateway is basically acting as a bridge, okay, in between different types of communication technology, and also helps in, apart from that, it also helps in data filtering and security application. This is another important feature. So gateway is not only providing the or not only resolving the interoperability issue, rather than it is also providing you the data filtering and security implementations. And this software part of this gateway is specifically for build, because there may be multiple devices and you want that, okay, only this device have to provide it the access. Okay, because in IoT we are connected with the internet, and that internet can be hacked. Okay, so if that internet can be hacked, your devices can be hacked, and any person can breach your personal space. So for that, a gateway providing you the software capability that, okay, which device has to give access to be connected to the internet. And this software capability of this gateway, of these gateways, is referred to as an edge computing. And that edge computing is another uh, uh, a big buzzword today's scenario, and lots of research work is going on in this area, that how can we do edge computing. Okay, where most of the computational part is done at the device side. Okay, and and only at the device side, which are referred as edge devices. So sometimes these D1, D2, D3 are referred as edge devices. Okay, computation parts means filtering, security, and processing. All these things are done at the device side itself. So this is a more generalized model. That is what is referred as device to cloud gateway model. Okay. Now last model is, we have fourth model is called the backend data sharing model. Okay, in this backend data sharing model, what is there? Actually, um, devices are either there is a means you can understand, either we are sending this data of device using the device to cloud model, or either you are sending the this data either using the device to cloud model via IoT gateway. Either of device two models can utilize to send the data to the cloud. Okay, but what we will do of this data which we are sending, right? So this cloud is actually used for multiple purposes. Previously, generally it was only utilized for the purpose of storing the data. Nowadays, the lots of commercial vendors are there, and commercial cloud vendors are there like AWS, Microsoft Azure, IBM. So all these commercial cloud vendors are providing some of the capabilities specifically for, they are having some capabilities, are providing some capabilities of analytics, and also the capabilities of prediction using some machine learning models. So all these can be done. All this uh, processing part, huge processing part, can be done at the cloud level. So we are taking the processing to the cloud. So what would happen sometimes, that the cloud that we use or utilize uh, doesn't have that capabilities. Okay, so what you can do, suppose for the initial purpose, what you have done, you have utilized a cloud which is free, and you are storing the data over here. After some time, you have realized, okay, we need some analytics to increase the business, and we require some analytics capability. So what would happen in that particular case, that you need that type of cloud which is having that capability, some commercial cloud. So what you can do, you can share your data from one cloud to another cloud, utilize these services, and later on again get the result to the same cloud, right? So this concept of sharing the data for the purpose of some analytics or some other use, or to increase the capability of the cloud for storing purpose as well, this model is utilized at what is referred as backend data sharing model. Okay, so I have written also, the cloud outsources data into different clouds for performing different types of operations like analytics and ML. So in general, if we'll try to summarize this this concept into a one slide, so this is the best way to represent it. That is the what are the different components of an IoT ecosystem. So let me summarize it. That if you want to develop or to want to work or want to create an IoT framework, so what the least thing that you require, that you should have a thing first of all, and that thing may be equipped with some sensors or actuators and should have the capability of communication or internet capability so that it can communicate over the internet or have some protocol mechanism so that it can be connected with the gateway. Okay, just on the right hand side, you can see there is a specific device XM1000, and this XM1000 is having the capability that it is having 2.5 gigahertz RF protocol system, and also it is equipped with two different sensors. Now these devices, there may be multiple such devices, and these devices can also form a network. Maybe there may be a point-to-point network with the gateway, or they may also have a network of like they may using some ring topology, or they may also having mesh topology. Any network they can form, and they may connect itself with the gateway. With the help of gateway, we can connect these devices to the big internet framework, okay, or structure to communicate these devices or send their data onto some remote servers or clouds. Okay, from their clouds also we can have some remote computer, some dashboard where we can read the data from the cloud or access these clouds. Okay, so cloud, we can, what we can say, cloud is an interface in between the device, in between the two devices which are very far away from the remote, which are very far away from each other, and they may be at any place. So we can have the communication via cloud. We can send the data from one device to cloud, and from cloud to some remote computer, and similarly from remote computer to the cloud, and then to the remote device. So in this way we can establish a complete monitoring and control mechanism for controlling our devices over the internet from any place all over the world. So this is what we referred a complete framework of an IoT or an IoT ecosystem. So is there any doubt to anybody till that time? Anybody of you, if you have any doubt, you please ask me. Okay, if there is no doubt, so let me proceed. Let me proceed further. Now the concept is that uh, whenever we are transferring the data from one device to the another device, from let's say one device is at one place over here, and another device
Hello,
it's
sir.
at some other place.
Hello.
Yes, please.
Hello. Sir,
Yes,
can
yes.
you explain the backend sharing cloud?
Yes, definitely. Backend sharing model is a model in which, let's say we have a device, and that device is sending its data onto a cloud. Okay, and on a specific cloud. Let's say you
Can
have
you share the slide?
okay, one second. Let me check it out. Yeah. Okay. Yeah. Let's say we have a device D1, and that device is sharing its data with some cloud, right? And that cloud is first of all, it was utilized this cloud for storing the data only. Okay. Um, later on, the person realized, okay, we want some machine learning and some analytics capability so that we can increase our business. Okay, or we can see how can this data can be utilized to predict the future growth of the company. But that cloud is do not have that capabilities. So what we realize, without without replacing that cloud, but he realized, okay, we can further share this data which is available at cloud 1 to some other clouds, cloud 2 or cloud 3, which are having these capabilities of analytics and machine learning so that they can provide us the feature. So this sharing of data from one cloud to another cloud for the purpose of some advanced processing or for storage purpose itself is termed as backend data sharing model.
It is
Is it
cloud
clear?
to cloud communication.
It is also, yeah, the one cloud is sharing the data with the other cloud.
Cloud to cloud communication.
Yeah, cloud to cloud communication.
How many types of clouds?
How many types of cloud means?
Types of clouds.
There are different there are different basically you can say services that we can utilize from the cloud. Okay, like आपने सुना होगा SaaS, PaaS, like the service model is there, and then there is a means what we can do. Cloud is nothing but it is a space which you can buy for your purpose, and when for which purpose you are for utilizing it, depending upon we have different types of service as a service. I'm not actually remembering exact terminology. It is SaaS, PaaS is like this. These are the you can say models, or you can say ways where you can configure your cloud. Okay,
Sir, types of cloud, sir.
types of cloud, I don't know what you are actually referring to. Cloud is a cloud. If you have any information regarding it, you please let me know so that I can connect to the context.
Personal storage cloud, public storage cloud.
Okay, so if for this IoT application, we are definitely we are utilizing, suppose if an industry is buying this particular cloud, so that would be it's for personal use of the industry itself. And but if a particular organization is buying the cloud for sharing it with the group of people, so definitely it would be a public cloud. So it depends upon that whether you want to make your data available to the every person, so you can put it onto the cloud. And if you want to utilize that data for a group of person or for a group of people in the organization, definitely there would be a private cloud. Okay,
Okay, sir.
so in this scenario, the context is that it hardly matters whether it is a private cloud or it is a public cloud. The context is basically we can share the data from one cloud to another cloud depending upon our requirement. Okay, so let me move forward. Yes, so now let's come to this point. This yeah, so yeah, I'm telling you that in the IoT framework, what is there that there may be a one device, and if you want to communicate with another device which is very far away from each other, okay, or with another device which is at some remote place, okay, so you have to utilize the actually networking, the internet structure, right, with the help of internet. So you can connect your device with the gateway, and further that gateway would be connected with the internet, and with the help of this internet the data is transferred, okay, from one point to another point. And we know that when we are talking about internet communication, then there is a concept of OSI model. So this is always into the picture. So the networking aspect, this is what we referred as the networking aspect of the IoT. Okay, what is there at the networking side? So we are very much aware about this OSI model, and we also know that this OSI model is further conceptualized into a TCP/IP model, where these layers are merged, their workings are merged, and they are referred as physical, network, transport, and application layer. Okay, then utilizing this TCP/IP, because this your internet is specifically utilizing your TCP/IP model. So at this TCP/IP model, at every layer, when your data is transferred from one point to another point, so it is utilizing this layered structure of TCP/IP model. So at the lowest side, we have a physical layer, then we have an internet layer, then we have a transport layer, and then we have an application layer. Okay, so at every point, suppose your device is sending the data, so that is what we refer as a device model. Sorry, physical model, physical layer. So at physical layer, we have some sort of protocols. Okay, for communicating your device data to the gateway, right? So these protocols are utilized at the physical side, physical layer of the model for transfer of the data. What are these protocols? Already there are some protocols available in the internet layer. We are very much aware about it. We were utilizing it from several years. But what is the point in discussing this particular slide? The point is that specifically for IoT, there are some protocols added at every layer so that this IoT communication can be established even in some of the worst conditions. Okay, worst condition means there may be a low bandwidth situations. There may be a high data rate situations. So like that. So in case of that, what are the protocols that can be deployed or utilized so that these challenges can be overcome? So similarly, we have different protocols introduced at the different layers of this TCP/IP model for supporting the IoT communication. Okay, just like for an example, if we'll talk about that internet layer. So at the internet layer, we can see that there are two more protocols are there. IPv4 and IPv6. We know that it is used for addressing, but 6LoWPAN and RPL. These are the two new protocols that has been introduced at this layer, specifically for low powered applications. Okay, if you want to have create a if you want to have low power applications for transferring of the data, okay, so you can utilize these type of so you can create this type of low pan network. UDP TCP are there already. There is nothing new at this layer. At application layer, we were very much familiar about the HTTP and HTTPS for security purpose, but there are some more protocols have been added, just like XMPP, COAP, MQTT, AMQP. These are some new additions at this application layer, specifically for low bandwidth situation. If you want to transfer your data or establish communication, right? So these are, I'm not going into the details of these protocols presently because we have a short of time. So just for your awareness, what you can do if you want to work specifically for computer science students who want to work in this particular domain, they can work on the networking side of it and they can utilize and learn about these protocols, what these protocols are utilized. Let me give an example. MQTT protocol is a very important protocol nowadays, and it is utilized in smart home automation. Even our Facebook Messenger, the Facebook Messenger that we use, it utilizes this particular protocol. It is a publish and subscribe protocol where you can where you can utilize this protocol for sending your data. Okay, so it can work in a low bandwidth situation, and where do you do not want to sending high data rate, or you want to sending more data. Okay, so this is specifically utilized for that particular purpose. Similarly, some other protocols are there. So every protocol has their own importance and utility. So I advise you can learn about these protocols and explore. Okay, so what are the networking consideration and challenges that I was talking about that you face while whenever you come across about IoT? So there are some of the networking consideration that we always talk about. Whenever you want to set up an IoT environment, what we need basically we'll talk about these. We have to keep in mind these specific points. The points are range, bandwidth, power usage, intermittent connectivity, interoperability, and security. So these are some of the constraint basically that that we should have to kept in mind whenever we are trying to set up an IoT environment as per our application, as per our the requirement of the application. Okay, and these points are self-explanatory. Let me give you introduction about all these points. Range will decide that okay, what is the distance of communication where you want to communicate your data. So accordingly, you have to choose that protocol. BLE is for short range. Zigbee is also for short range. Now, if you want to come, short range means somewhere around from 1 meter to 2 meter or 4 meter maximum. But if you want to communicate your data over a large distance, so accordingly you need to choose some other protocol. Like in IoT, we have some more protocols like LORA, that is long range protocol. Okay, or and we have protocols like which can work over the cellular technology also. Okay, so you can utilize that type of protocols depending upon your distance. Similarly, bandwidth. Bandwidth means what your application requires. What is the bandwidth requirement of application? You want to continuously transmit your data, so it requires high bandwidth. And as well as if you want to transmit the videos or things where which we require high bandwidth, so definitely you have to utilize that protocol which supports high bandwidth. Okay, similarly, um, if you have a low bandwidth requirement, you can utilize that type of protocol. Just I told you, like MQTT, it can work in a low bandwidth situation. Power usage. While choosing a particular protocol, you should keep in mind that what are the power requirements of an IoT structure, right? Um, because as I told you, most of the systems are battery operated, so you require low power solutions. So in an IoT framework, there would be a low powered protocols for short range as well as for long range. Like LORA is one of the low powered long range protocol. This is just like Sigfox. This is also a long range and low powered protocol. Similarly, BLE, Zigbee, these are the short range protocols with low power. So accordingly, you need to utilize. Okay, then intermittent connectivity. There should be intermittent connectivity means there should be a perfect connectivity. If you want to utilize your data for continuous streaming, then there should be intermittent connectivity. But if you want to utilize your data for periodic monitoring, means suppose you want to monitor your data for each after 1 hour or each after 2 hour, then accordingly you have to provide the intermittent connectivity for that. Maintain the intermittent connectivity. Interoperability we have already discussed. Security, yes, security is very much important and aspect, as I told you, that because we are using the internet and it can be seen by many eyes, and because this IoT is into our personal space. Okay, we are deploying it for the personal space and for controlling our devices, so anybody can hack and further can breach the code. So security is very much important and it can be applied at different level of the hierarchy. You can apply the security at the hardware level at your device side. You can utilize the security at the application layer also. Even you can apply the security at intermediate networking layer also. There are some standard encryption algorithms available which supports this security aspect. But further additional security you can use protocols accordingly, and you can use security algorithms accordingly. So these are some of the requirements and design challenges that an IoT engineer are facing and or should keep in mind while establishing an IoT framework. Now let's jumps onto the popular hardware platforms for IoT. Okay, so there are lots of nowadays because there's lots of proliferation has been done in IoT hardwares, but there are some of the general hardwares. So I have downloaded the list of top 10 popular hardware platforms for IoT, and you can find out that these all these are some of the IoT platforms like Raspberry Pi, Arduino, ESP8266, and then we have Intel Galileo, BeagleBone, then we have Banana Pi, Nodemcu, Flutter. This is the list of top 10 hardware platforms, and we can utilize these platforms for the purpose of development of the IoT application at the device side, at the thing side. Now, what is the utility and which platform we have to utilize at for which purpose? Let me take an example to just for your introduction to understand you people. How can you choose? Let me talk about this Raspberry Pi. So in this Raspberry Pi, you can see that this Raspberry Pi is itself a whole motherboard, you can say, in a very compact size, in a credit card size, a small credit card size, which is utilizing a very powerful processor of almost 1 gigahertz. Okay, and having core ARM Cortex CPU on it, which is the latest in the market. Okay, ARM Cortex CPU. So it is utilizing this that CPU. It is having Ethernet port, 4 USB port, GPIO pins, camera interface. Then it is also having a monitor interface, audio interface. So it is also having its GPU specifically for video processing and image processing applications. So you can see what a motherboard in a CPU is having. It is having all these things on it. Even it also run on an operating system, just like our normal desktop run. And you can what you can see that it can uh, see
Hello,
that it is of how much small
hello,
size. Yes, please.
hello.
Yes. I'm audible.
Sir, can you again repeat the platform requirement for software?
Yeah, I'm on to
Popular
it.
hardware for popular software for IoT.
Popular software for IoT.
Yes.
We have not no slide of popular software for IoT presently. We are discussing popular hardware platform for IoT. Later on, I have slides for popular cloud platforms. Okay, so there where I will discuss upon it. Right. I will highlight, if you will say, I will highlight some of the softwares that you can utilize for developing your application and research purpose in IoT environment. However, I have not made any slide regarding popular software platform for IoT, right? But if you will say, if you are saying, I will highlight at the end that what are the softwares that you can utilize for development purpose. Okay, for at application level or at the device level or for the research purpose as well, right? So yeah, I was discussing about the Raspberry Pi platform, and you can see that this Raspberry Pi platform is having so much things that a desktop is having, and because it is having so much things on it, it can be utilized for such applications which are computational intensive. It is better utilized for such applications rather than blinking the LED or monitoring some sensor data. We should have to utilize is for that purpose, which actually requires some powerful and computational intensive requirements. Okay, because it is having that capability. Also cost matters because it is of if you'll buy it from the market, it is somewhere around 4,000 rupees, 3,500 to 4,000 rupees. So it is a costlier solution. So definitely we should have to utilize this costlier solution for that purpose which actually requires it, rather not choose it for that purpose which would be served by some other low cost solutions. Okay, right. So this is one thing. Another thing is that Arduino and the combination of ESP8266 can be utilized for the purpose of low level development of applications if you want to monitor the sensor data, and which we do not require, where we do not require some more computational intensive applications. Okay, because it is an 8-bit, there is an 8-bit microcontroller on it, and it can be utilized for that purposes. However, Raspberry Pi board is having a 32-bit processor architecture of ARM Cortex and very high frequency. This Arduino microcontroller work on 16 megahertz, and you can see Raspberry Pi processor work on 900 megahertz. So there is a huge difference, you can understand, right? So where we require low cost and low processing and low level development application, where you can utilize Arduino in combination of ESP8266. Similarly, if you want high processing in low cost, right? There is also an option which is nowadays very much popular, uh, that is Nodemcu. It is also having a 32-bit processor, and it works on ESP. In it, what is there in it? An ESP8266 Wi-Fi chips has been mounted on it. So uh, itself, so it is a complete IoT board, and it is also having a 32-bit processor from Express if system, which is having a reasonable frequency, and you can specifically do that type of tasks which are little bit computational intensive, not video processing specifically, because there is no support for video processing in it, and audio processing. But what you can do, you can utilize some more computational intensive tasks, which is not supported by IoT, which is not supported by Arduino, right? So this is basically the context, in short, to understand that which particular hardware device you should have to choose as per your requirement of the application. Okay, what is the requirement? Nowadays, one more board is there that is based on ESP32. Okay, just like ESP8266 is, ESP32 board is there, which is also very much popular, and it is being utilized specifically in smart wearable devices, smart home devices, for the purpose of the low power development. It is an ultra scale low power device and supports very low power modes so as to support your low power development applications. So nowadays industry people are focusing on it and utilizing it for developing their products. Next is the popular cloud platforms. I have already told you that because you want to communicate your data from device to the cloud in using some sort of model. So what you can do, you can you can utilize the cloud platforms again as per your application. As I told you, if there is no much you want to utilize it for only for the purpose of storing the data or for displaying it on a particular specific dashboard, so there are some free clouds available. You can utilize that free clouds, like ThinkSpeak is there, Firebase is there, Arduino Adafruit IO is there. So these are some of the software clouds which you can utilize for that purpose. But if you want to do some commercial uh, work where you want to utilize it for the purpose of analytics or machine learning, and you also want that these particular clouds should support networking protocols, so you have to go for the commercial clouds. So most of the industries who are working in this domain, they actually utilizing these commercial clouds. Some These are the three most popular commercial clouds which I encounter. That is IBM Watson for IoT from IBM, and Watson IoT from IBM. Then there is a AWS IoT from Amazon, and then there is a Microsoft Azure IoT suite from Microsoft. There may be some other also. Okay, and you can check it out on the internet, and but for the listing purpose, I have put it over here. Just now one person asked me what are the popular software platform for IoT. So software platforms includes basically software platforms includes the what type of software we should have to utilize. So at the device side, it depends upon which type of microcontroller board you are using. So supporting that, we have different different types of editors. If suppose for an example, if you want to have Raspberry Pi, so we have a Raspbian OS for that. In that there is an editor itself, there is an editor, you can write the program over there. If you are utilizing Arduino and Nodemcu, you can utilize your simply your Arduino ID for that particular purpose. Even if you are using ESP32, you can use Code Computer Studio. Okay, or or even you can utilize Visual Studio Framework also, because it also providing the support for all types of microcontroller boards, right? So this is the at the device side. And for research purpose, specifically if we'll talk about the research purpose, then for fog computing, edge computing, at the networking level, if you want to simulate how your data is transferred from one node to another node over the internet, so you can utilize iFoxim. Okay, and there is a cupboard simulator specifically for simulating IoT environment, like that. Okay, similarly at the application layer, you have different types of application softwares specifically for performing this, right? So I hope I have able to give you the answer of your popular software platforms. Now, which type of applications basically you can make it out using this IoT and cloud scenario. So we have some we our my BTech and MTech students have published some of the work on it, and initially at the level where we have one paper we have published on pollution monitoring system, and which is based on vehicle pollution monitoring control and challan system using MQ2 sensor based on IoT. It is published in WPC journal, which is a very reputed journal of Q3 level of Springer. Okay. Similarly, we have another case study which is based on weather monitoring station on cloud. It was we have published back somewhere around 4 years back when we have initially started to work upon IoT. So let us discuss how we have actually formulated their block diagram and what we have utilized it. So in the pollution monitoring system, what you can see over here, that there is a Raspberry Pi board. So presently, when we have start developing this particular project, so we have utilized a Raspberry Pi 3B model, and that Raspberry Pi 3B model doesn't have onboard ADC in it. Okay, so what we require, we have connected one ADC interface, and with the ADC we have connected MQ2 sensor. MQ2 sensor is a sensor which is utilized for sensing different types of gases in the environment, and that gases are because analog in nature, so we require an ADC. So we have used a separate ADC chip specifically for that purpose. Nowadays there is some Raspberry Pi boards are coming. Raspberry Pi Pico is there, which is providing onboard ADC as well. Okay, now once we have sensed this data, then what we can do, we can display it onto the LCD, that what are the readings. So we have actually made this project from the point of view of from point of view of controlling the pollution, because nowadays we are living in the NCR region, and NCR region is basically in specifically not in the NCR, in the metro cities we are facing this pollution issue. So, and most of this pollution are coming from the moving vehicles, right? Because of not proper servicing, or they are using the old version of their engine, or and so anyhow we can try to minimize that pollution as much as possible. So we have developed this particular system, and this system can be mounted into the car, where at the dashboard you can place this LCD, and this sensor you can put at the exhaust pipe of the car. Okay, you can make the arrangement accordingly. Here motor represents the vehicle of the tires, or you can say the vehicle of the car. Okay, and there is a buzzer. So what happens that whenever the sensor senses some pollutants from the environment, and if they are, and it is displayed onto the LCD. Okay, and the driver or the owner of the car can visualize these labels, and if that particular labels are going beyond to a certain threshold limit which is set by the uh, government body, then what we can have a buzzer to indicate to the person that okay, your pollution level is rising, and it requires your car or your vehicle is requiring some sort of servicing. Okay, and if the driver will be given a certain amount of time for that, for performing this work, and if driver would not uh, follow the rules and not get service their vehicle within a specified amount of time, that then what we have done, we have generated a challan, and for that an email would be sent to him, to their according to their registered vehicle. And what he can do, by we have also created a web application for it, where the user can enter their car number and then fill the challan. Okay, at the same instant of time we are sending this data onto the cloud, think speak cloud, which where the authorities or some person, a centralized solution would be there, where a person can monitor the vehicle of the can monitor the status of the different pollutants level for a particular vehicle. Okay, So in this way, this application has been formulated. This was the work of one of the MTech student over here under me. And next is weather monitoring station on cloud. So weather monitoring station is a station where what we have tried to do, that we will try to make a robot, okay, which can actually which can which is equipped with the Raspberry Pi and DST11 sensor module having temperature and humidity, which can measure the temperature and humidity. And what we have done, we have made it movable with the help of IoT technology. So we can control this particular module from anywhere, and from anywhere, and move it so that it can measure the temperature and humidity for different places. We can utilize this robot for defense applications, or for the application where required some urgency. Okay, so they can actually measure the temperature level and humidity level, and accordingly we can monitor it over the cloud from a remote place. Okay, where humans cannot go, the robot can work accordingly. Okay, so yeah, this is how you can create the dashboard on Things Speak platform. This is a cloud platform. You can configure it, and in this way you can represent the things like temperature in Celsius, temperature in Fahrenheit, similarly humidity. So these cloud platforms can be configured, uh, and you can create your dashboard over there, so that you can monitor your data in a very efficient manner. And right now, next, AI versus ML. Okay, so now this is again how actually this AI is going to be connected with IoT. What is the concept that are being utilized with this IoT? So let me start with, first of all, basically what is AI and what is ML, because there is a difference between these two terminologies. Can anybody, any of you, any of the student, or anybody from the listeners would like to highlight what is the difference between AI and ML? Anybody of you? Any of the student who would like to, or those who are listening who would like to give their views, what is actually the difference between AI and ML? Are these same or they are different? So anybody would like to participate? Okay, no issue. So let me come to the point. Actually, artificial intelligence is a wide term, and with a range application ranging from robotics to text analysis. What is the meaning? Basically, uh, AI is a big word, and it comprises and what we can say, a machine learning is nothing but it is a subset of AI. It is a small part of AI. Presently, what we are doing, what we have learned, or what we are aware of about these two terms, AI and ML. Actually, it is all ML. Suppose we are doing some text analysis. Suppose we are using some optical character recognition. Suppose we are doing some image processing. Okay, some like all these work. So all these are nothing but these are machine learning. Okay, which we are doing separately is for a specific task. What is AI? AI says that it when all these different machine learning subsets of machine learning developed for different applications are combined together for one particular task, there where we can say it is an AI, complete AI. Okay, because it is still a technology which is under evolution. Okay, and whether, and there are arguments of whether we should be aiming for high level AI or not. So basically AI is a wider term which comprise lots of other machine learning subsets. That's why it is written robotics, whether we are working on robotics part or whether we are working on time. So आप लोगों ने मूवी देखी होगी एक, जिसमें एक हमने अभी डिफरेंट डिफरेंट मूवीज आई हैं, एक बहुत ही फेमस मूवी थी जिसमें हमने देखा रोबोट 2.0 जो हमने देखी थी। इस तरीके की जो मूवीज आई हैं ये, इसमें देखा आपने कि इस तरीके का एक रोबोट बन गया which can do multiple tasks, which can do, means a human can't think of, so, and having the capabilities of more than human and way beyond the human. Okay, that robot can do uh, um, um, unexpectable tasks which a human supposed to do. Okay, and with a fraction of seconds. So there where we can say this is a high level AI. Okay, right, because it comprises of you can see that robot can also uh, um, um, uh, can do image processing, that robot can also do text analysis, that robot can also do, can move, means it can predict, it can learn, it can, means it can it comprise several machine learning tasks in it, and then there it would become the single entity, uh, right? So this is what we is termed as AI. Presently, there is a misconception. Presently, till date, what we are learning is all about ML. Still, we are in the development phase. It is still evoluting. Several people have achieved something that they are able to achieve. They have achieved. They have tried. They have developed some robots for the purpose of like one robot is there as a radio jockey which can answer your questions, but still there are lots of more things to be done and lots of more can be added into it so that it can match the fiction of the movies, right? Machine learning, as I told you, is a subset of AI that focuses on a narrow range of activity, right? Now, apart from these two, there is one more term that is called data analytics. So some people also confuse, now what is data analytics? This is AI, this is machine learning and data. So data analytics is nothing but it is visualization of data into a some representable format, right? There is another one term that is called data science. Most people also confuse with data science and data analytics. Data science is visualization of this particular data and do and some prediction also for the future purpose or for the representation or for the growth of the company. So data and science actually requires a person who have the knowledge of machine learning algorithm so that it can analyze the data and do some prediction task. Data analytics is only specifically the representation of data using some sort of softwares, okay, and make some story on it. Just like MBA people now people does generally, they analyze the data and depending upon they prepare their product their project report representing the sales forecasting of the product or something like that. So these are some of the terms and we should aware about these terms, terminologies and the meaning of each and every term, right? So that's why I have put it onto it before actually connecting it with the IoT. Now, how can we achieve IoT in terms of hardware? How can we achieve AI in terms of hardware? So presently, if we'll talk about normal IoT thing or device, we can say, so what is there? There is a processor, there is a computer board, it is having some data inputs, we'll write some program, data inputs or means some sort of sensor, okay, and it is sensing something and we have a program, and accordingly depending upon that program we can take some actions and we can generate the output. So this is the traditional way of programming of embedded devices or IoT devices. Now in future or presently those companies who are developing AI solutions at the hardware level, what their approach? That traditional programming has changed now. The programming has been changed into a machine learning programming at the hardware level. In that case, there is still a board or a computer, okay, which would be the centralized part. But in machine learning, what we have a data and we have an output. which would be represented to the machine. Okay, the inputs and outputs are represented to the machine. Means we have a sensors and the output of these sensors are also represented to the machine. And based upon that, this machine learn using some set of algorithms. We have specific algorithms for this machine learning, like neural network, like Bayesian, nowadays CNN. Okay, deep learning will go into the deep learning. Okay, part. So we have different sort of algorithms. So what we do generally, we'll write that algorithm in this computer, and that algorithm when executed would learn based upon the data and output presented to it, and accordingly it will generate a model which is referred as program. So you can see that how the traditional programming method has been changed in the case of machine learning development, when we actually want to deploy this machine learning models onto the hardware. Actually, what approach you have to actually choose? Okay, now how AI is related with IoT? Okay, now we have seen that in the previous slides about IoT, that we have we are sharing the data onto the cloud, and I have already told you that the most of the processing part of the cloud of this particular data is done at the cloud part. And nowadays cloud is not only used for the storage purpose, rather than they are used for the purpose of machine learning and analytics, having analytics capability also. Okay, so what are the scenarios or what are the things you can think of this AI is applied in IoT? Okay, you may be amazed to know that there may be a lots of devices and sensors which are connected to each other over the internet, and they are generating more than 3.5 quintillion bytes of data daily. Now you can assume, I don't know how much it is actually. I have taken from the internet 3.5 quintillion bytes of data daily, and this data holds a lots of information actually. From the point of view of industry, okay, this data is having very much importance for the growth of their company. Okay, based upon this data, actually they can see the behavior of the customer, purchasing behavior of the customer, utility behavior of the customer. Okay, and accordingly they will provide some sort of solutions to them, offers to them. Okay, so it is having some important information. For this information, you need some analysis, some prediction for the growth of business in the smart home, self-driving cars, and many other fields. Okay, and it is not an easy task to find the information uh, from this data, useful information from the data, and for that we require some sort of AI, or you can say in other words, nowadays now you can understand when I am referring AI, means I am referring to ML. So you need some sort of machine learning capability so that you can extract that information from the this used data. Okay, right? So basically what we say that this AI is nothing but it is the brain that will enable analytics and decision making for the data collected by IoT. Okay, so in other words, we can say IoT collects the data and machine learning process it in order to make sense of it. Okay, so this is what is the role of AI in IoT. Now from where, what are the different scenarios from where this data is generated? Okay, where you can apply this data basically. We'll see that. If we'll talk about the technologies as compared to IoT and artificial intelligence, so these are some of the things, technologies that are very much popular nowadays, and you can see IoT and AI are at the top. Okay, in this scenario. Okay, where you can do some substantial investment for the purpose. Okay, next. One more thing that I told you, that this AI is actually is in the evolution phase. Evolution phase means it is still developing, and we are very far away from now onwards. We are not still purely evolved the AI. Okay, where we have a machine which is compatible of that type of robots which are having capabilities more than the humans. Still it is in the development phase, right? However, this graph will tell you the scenarios that there is a green scenario, there is a blue scenario, and there is a orange scenario. Okay, green, blue, and orange, there are three colors you can represent, which representing that AI, green representing what is the AI capabilities of today, and this red or orange you can say representing the AI capabilities processing progressively increasing, and this blue is representing AI capabilities unlikely in the near future. Okay. So what is there, we can see that nowadays whatever we are seeing in front of about the machine, like Alexa home assistant, we are there, and there is a Google assistant is there. Okay, where you can say something and it will reply you automatically. Chatbots are there. So we are actually in the green phase, and where we have developing some sort of, we have developed some sort of small robots and machines which are working as per our instructions, and they are quite intelligent. They are when we train them, they're quite intelligent, that they are replying to our queries, but with some limited capabilities. They are not perfect as equivalent to a, they are not perfect as to a equivalent human, right? So uh, we want to develop that type of robot which can think of like a human being, and answer almost more than the human being, we can say, and having all sort of capabilities. Okay, so we are in the transition phase from green to orange, basically, where initially we have start developing this ML applications for image processing and your optical character recognition or text recognition. For we were using it for this. Still people using for this. Now we are able to develop some sort of robots, like as I told you, radio jockey robots, and there is one also robot which have been given the citizenship in Dubai. I presently am not just remembering the name of Sophia. Yeah, Sophia. So Sophia is the robot which have given the citizenship at the Dubai. Okay, proper man citizenship, and it is having some more capabilities. And so we are in the transition phase now from this green to orange. And what we want in future, after 10 years or 15 years or 20 years, what we are seeing that we want to develop a type of robot which is far more than the capability, having the capabilities far more than the human being. Okay, and as I told you that everything is having some advantage and also disadvantage. So there is also a disadvantage of this AI, and also there is one scientist who told that you may maybe heard that the name of the scientist is Stephen Hawkins. What they said basically, this the devastation, one of the reason of the devastation of the earth may be AI. So by the 2040 or 50, what we have, we can or we may able to develop that type of robots, or that type of robots which are having capabilities more than the humans, and which can do the task of thousands of humans by themselves alone. Okay, and if that particular AI is becomes uncontrolled, and it can be done in uncontrolled manner now, and that we have seen in some of the movies also, then it would lead to the devastation of the earth. Okay, there may be an end of the era. So there are some experiments have been done already, and researchers had find out that okay, there may be some serious disadvantages of this, and some at some laboratories some research have been started, but later on that research has been stopped, specifically by seeing that okay, there may be some disadvantages. So the things are evolving, and soon we'll see that okay, by the end of the 2040 or 2045 we have some sort of robots which are quite efficient and quite capable, and where we can say yeah, this is true AI. Yes, I was talking about data where you can generate the IoT data basically, because if you want to train your machine, you should have a data, and IoT devices are the big source of this data. But what are the applications basically, and what are the ways from where this IoT data has been generated? So data that helps cities predict accidents and crimes. You can think sort of application, you can design and think sort of project which is for this purpose, which will predict accident and crimes. Data that gives doctor real-time insight into information from pacemakers of biochips, so into healthcare domains. Data that optimize productivity across industries through predictive maintenance on equipment and machinery. So you can think of a project like this, like in smart grids we have, and it is supply chain management we have. Data that creates truly smart home with connected appliances for the purpose of utility of the measurement of electricity, or for providing a good comfort to the people. Data that provides critical communication between self-driving cars, which is another promising area. Mercedes-Benz a type of companies are working on this, like Tesla is also there, which is these companies are working on self-driving cars. Okay, so this is there where the data is there, and this data is from IoT devices, and this data is having useful information which can be utilized for the purpose in different scenarios as per their applications. So you can think of having an application which can combine IoT and AI together by formulating these applications, by formulating an idea based upon these applications. Okay, for an example, just to motivate you people, for an example, suppose our homes are managed by IoT devices and sensors, and we can assume that our refrigerator is connected to the sensor and we do not have bread and milk. Okay, suppose our refrigerator is quite smart and it is having some sensor, and it can also having the capability that it can connect with the internet. So it keeps on monitoring the inventory inside it, like bread and milk. And suppose there is a bread, we don't have the bread and milk is out of short. So since it is connected with the internet, and so your refrigerator will look after it, you don't have to bother about. It will place the order by itself to the nearest supermarket, okay, which may be using some robots or drones for sending the groceries at your doorstep. Okay, and mm, now as the supermarket gets the order of bread and milk, they send the order by the drone or robot, which will deliver the order to your home. There where you can use the IoT technology with the AI, which make our lives easier. And at your home also, there may be some sort of robot which will collect it, and or you may put uh, if there is not a robot, then at least you can do that. Okay, you can receive the order from that robot and you can put it back into your fridge. So at least your fridge is monitoring and taking care of all these things for your day-to-day needs, and doing all these stuffs for you. Okay, another example is the weather reports, where you can use the sensor to monitor the weather and send live weather data to the weather statistics, which will analyze the report and predict the weather. One such applications we have actually developed, and we have also published a research paper on it just last year, and it was done by my BTech students, where they have done they have implemented a real-time weather prediction system using IoT and machine learning concept. So this paper is already there, and you can utilize it for the purpose of um, 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 uh, you can read it out as per your requirement. Okay, so I have put the reference for you people. So this is the structure I have taken for you. You can see that there is a centralized Nodemcu board, IoT board, and we have connected two sensors. One is DST sensor and another is LDR sensor for checking the light intensity and as well as the temperature and humidity. Okay, and you can utilize this system for different purposes. Okay, um, And what it is doing, it is continuously sending its data onto an HTML web page as well as onto a cloud. Okay, and what we are doing, we are taking this particular data from cloud, which is sending to this. We are taking back this after certain interval of time. We are taking this data again back into the Nodemcu and send it for the and trained a model at Jupyter Notebook. Okay, and send this data for training purpose at the machine learning using some machine learning algorithm to our Jupyter Notebook at our computer. There where it is predicting and sending back the output to the Nodemcu, and that output would be displayed in terms of LED. That prediction would be done in terms of yes or no, let's say. So accordingly it will be sending back to, because let's say we have designed such a system that okay, it will require, okay, if certain temperature or humidity or light values are above the threshold, so you will give yes or you will give no. So accordingly this type of system, so you can see in this what we have done, we have actually the, because Nodemcu is an edge device and we want some low level development, so we cannot use it for running the machine learning algorithm on it, because it cannot run, because it is having a specific memory, very low resources. So we are utilizing it only for sending the data and for taking some decisions based upon the main part of the algorithm is done at our computer, but that communication is done with the help of Nodemcu. The algorithm is trained at our computer and the outcome is given to the Nodemcu so that it can take decision further. So in this way, these things you can formulate the things, right? These are some of the examples, actual examples I have taken for you people, so that you can understand that how can you formulate your problem. Basically the main problem is that there are lots of things are there on the internet, but the problem is that how can we formulate the problem, where we can start off. So these are some of the ideas I have implemented in terms of research paper, and you can utilize them, people can utilize them to make it more better experience, right? So now you can see in this slide there is a problem. The problem is that we need to utilize our computer basically for running the machine learning algorithm, because Nodemcu is having a Nodemcu doesn't have the capability. So I have two options: either we can run it onto a commercial cloud, but I do not, because my BTech students are there, so they do not buy the commercial cloud because it required some sort of some sort of money investment. So we are sustained with the ThinkSpeak platform. It is because it is a common open platform, but that ThinkSpeak platform doesn't have the capability of AI and machine learning capabilities. So you can see that in this particular problem we actually try to provide a solution which is very much suited to a student. Okay, and how a student can, if they want to develop their application, okay, either at the PhD level or at the MTech level or at the BTech level, how can you utilize it for the purpose of development? Okay, so there is a alternative ways of doing the same thing. But yes, if we have proper resources, if we have proper money investment, so what we can do, we can convert the same application and run it onto we have a different type of block diagram of this system. Okay, so for that we have two solutions: either we can run this algorithm onto the cloud, or we can go for some of the hardware itself. We can replace this Nodemcu, and there should be a hardware which can support this type of machine learning, okay, where we can run this. So there were we called as hardware accelerators for AI. Okay, so just a glimpse of for you people, just to wind up this presentation at the end for you people, that okay, how actually the industry is doing and how the research people can do if they want to actually execute AI onto the hardware. What are the prominent hardware solutions for it? Previously we have digital signal processor, as we know, and we can able to run some neural network algorithms on it for the purpose of optical character recognition. 2016 GPU comes into picture and they are working for AI. Even presently also we are using some GPUs, Google Colab like that, for running our applications, deep learning algorithms. Okay, But the question is that how can we put onto the into the hardware? So what we can do, we can have we can have that GPUs in a form of hardware, and we can put machine learning algorithm. We develop machine algorithm, write the code, and then dump into it. Apart from that GPUs, we also have FPGAs, which are the next promising solutions specifically for this. Now we have that type of advanced FPGAs, or you can say right word should be the SoC, system of chip FPGAs of RTX and Vertex families, which are providing you the support for hardware support for running your AI algorithm onto it. So there they are chips, FPGA chips, which can be reprogrammed again and again, and they are best suited for the purpose of research and development. Okay. After that, yes, we need some. Once we have done the research, development, we need an ASIC, application specific IC, so that we can develop a product. Okay, so some of the hardware accelerators already developed by some of the companies, like Microsoft is preparing for an AI chip for its HoloLens augmented reality headset. Google has a special NNPU, the tensor processing unit, which is available for AI on Google Cloud platform, which you are using for like Google Cloud. Amazon is reportedly working on AI chip for its Alexa home assistant. Apple is working on AI processor that will power Siri and Face ID. Tesla is building an AI processor for its self-driving electric cars. So there where the some of the companies, brand companies, big companies are working in this domain at the hardware level of running the AI onto the chip. So that's it with my presentation. Thank you all for hearing me patiently. If you have any questions, you please let me know so that I can able to answer.
Any question from the participants?
Sir,
Yes, please.
good afternoon to all.
Good afternoon.
Sir, most procedure of fast and grow comparison to Dell, HP, in which most processor of usable for more time and fast speed working in hardware. हेलो
मैं आपको क्वेश्चन समझ नहीं पाया, क्या बोला
सर
आपने?
मैं ये कहना चाह रहा हूँ कि सर जो हमारा प्रोसेसर है उसमें से किस कंपनी का सबसे अच्छा है और लॉन्ग टाइम चलेगा?
जो अपन डेस्कटॉप यूज करते हैं, लैपटॉप डेस्कटॉप यूज करते हैं।
हाँ यस सर।
मतलब इट इज फॉर जनरल पर्पस यूज और फॉर इफ यू आर आस्किंग इट फॉर, मतलब आप इसके लिए पूछ रहे हैं एआई और मशीन लर्निंग रन करने के लिए?
या राइट।
ओके ओके। एक्चुअली जैसे मैंने खुद अभी अपना सिस्टम लिया था, तो एक्चुअली प्रोसेसर तो आप कोई सी भी कंपनी का ले लीजिए जो आपका लेटेस्ट जनरेशन का हो। तो जैसे अभी मैंने i5 का प्रोसेसर लिया, इंटेल i5 का लिया है, तो बिकॉज इंटेल इज द बेसिकली द रेपुटेड कंपनी इन दैट डोमेन. What you need a GPU basically along with it, specifically for performing your applications which are supporting video processing and machine learning
नहीं सर अभी
applications
नहीं हुआ है।
and audio processing
नहीं हुआ है।
applications. तो आपको उसके साथ एक GPU लगाना पड़ेगा एक्चुअली में। तो आज की डेट में GPU बेस्ड सिस्टम्स भी आते हैं, और नहीं आते हैं तो आप एडिशनली आप GPU खुद से लगवा भी सकते हैं। तो दैट इज मोस्ट इंपॉर्टेंट. So it would help you to develop your AI and AI applications over it, and it would work for a long time. No issue in that. Okay, sir.
Any other question? So Dr. Gaurav Verma, I think there is no question from the participant side.
Okay, okay.
So I am very thankful to Dr. Gaurav Verma who took some time for this lecture from his busy schedule. So I would also like to inform all the participants that today at 3 p.m. we have another lecture on cloud computing. So this lecture will be basically given by, will be delivered by a person from the industry. So I think you must have enjoyed this lecture by Dr. Gaurav Verma, and you will also enjoy that lecture also. With this, I conclude this lecture. At last, I would like to request all the participants to please switch on their camera so that we can take the photograph. All the participants, please switch on your camera. Just a minute, one more photo. Thank you all. Yeah, I have a question from the participant that any feedback link is there for this session. So we will generate the feedback link and we'll send it to the registered email IDs of all the participants. Thank you. If any of you have not registered for this lecture, then please register, because only then we will be able to deliver to send you the feedback link. Thank you. Over to you, Dr. Kamlesh.
Thank you very much, Dr. Varun. It was a really wonderful talk today. We have listened to Dr. Gaurav. It was amazing. So we will meet at 3 o'clock in the next lecture. So that's all from my side.
Thank you.
Thank you very much.
Thank you all.